right, I think we can get started right at 11:40. Hey, I'm Christopher. I'm on Twitter's at Sexton. I was told it's good to give you a little bit about me to make, I guess, a more personal connection or something like that to the audience, and not just blast people with technical information, even though I feel like that's showing off, and what we're supposed to do is just shoot a lot of technical information at people as much as we possibly can. So I live in DC. I have a wife and 2 kids. I also have a small dog. She'll make a couple of appearances in this talk. On Twitter, I run a service wherein I tweet pictures of her in the morning and pretty much post nothing else. I work at a company called Redis Networks. We do products around proximity and location, often with mobile devices and Bluetooth-enabled things. Outside of the DC area, if that is stuff that's interesting to you, you like IoT, low-level firmware, and Ruby, come and talk to me. I'd love to chat. Also, the past couple of years, I've been helping out with a conference called Ruby for Good. We have another one coming up here soon in Virginia at the end of July 25th to 28th, rubyforgood.org, if that's your sort of thing, and you like helping charities and nonprofits. All right, the actual talk. So I gave this talk at the local DC meetup, the DC Rug, and one of the things that I failed to do at the beginning was explain what you should get out of this and what even ActionCable is. So I'm not sure how familiar everybody is with ActionCable or WebSockets, but we're going to step back a little bit and look at it, and then we're going to dig in really deep, and then hopefully at the end we'll kind of come back around to how everything fits together with a little more understanding. So the important thing to know about this is it's not magic. It's not really magic. There's tricks to it, and once you learn that you can dig in and figure out how it works, it'll make sense. I remember when I was a kid, I took apart my dad's computer, which he was thrilled about. It was an old 8086, and it had these 7400 series chips all along the side, and I remember prying them out of the socket and looking at it and thinking, I will never understand what this does. I then went on and got a computer engineering degree, and I found out that the 7400 series chips are just NAND gates. And once you understand what a NAND gate is, you realize it's not that complicated. And I thought, wait a second, how would I do this in Ruby? And it's not that hard. NAND is just, not and. So not, and then and I just wrote a method that returns it for us. And this is basically what those chips do. There's a whole series of them on the sides of the board. And so digging in and looking under the covers to figure out how things actually work seems more intimidating than it is. And so if this contrived example helps with anything, it's to give people the courage to do things like bundle open and dig into the source code of Rails or whatever Ruby gem you're looking at, because it takes a while to trudge through. But after you get in there and understand, suddenly things can click into place, and you'll realize that people wrote this, and so as a people you can understand this. All right. Like I said before, we kind of skipped the background of what is an ActionCable when I did this once before, and that proved to be very confusing for folks. So at work, we use it for things like digital displays or IoT devices getting configuration and sensor data in and out of different devices. And but what it works out to is everybody makes chat rooms with it. So when I was preparing for this talk, I did what I was supposed to do, and I made a chat room. So here is the quintessential example of what ActionCable is or does. So just run through on a chat room. I opened up 2 browsers. They're connected to my local Rails server. And I type in the message, and you see as I hit enter, the message just kind of pops up. And it works even if I switch over to the other window and type in the message. And it just kind of appears. So this is what we're going for. Like, how do we get this to work? I didn't want to get into anything fancy or the high-level business logic of what you can do in your app. It's much more of, like, what the hell is going on under the covers? Before we get to the what, let's figure out why we care about how this works. So one of the main reasons you'll hear, there's three, is we can do a server-to-client push. So whenever something happens on the back end, or a request comes in from somewhere else, or somebody at a different browser window somewhere that's not next to you types in a message and hits enter, an event happens on the server, and you can push it down to the other clients. There's this idea of it happening in real time, and I mentioned I was a computer engineering undergrad. When I hear this word, it makes me a little uneasy. There's a lot of connotation that comes along with using the term real time, and there's a specific thing called real-time computing, and that has strict real-time constraints that things have to happen within a time frame. That is not ActionCable. That is not Rails. That's not Ruby. Even the operating systems that we run these things on don't follow the real-time constraints. That is a whole separate thing. So whenever the sales team at Radius starts saying words like real time and it happening instantaneously, I always jump in and caveat these things. But what it does mean is we can get up to the minute or very quick, low latency response times that are faster than something like polling every 3 seconds. And then the other thing is overhead, and by this I mostly mean bandwidth. For a lot of types of traffic, something like a WebSocket connection is much easier on the bandwidth that it consumes. We used it for these IoT devices that sent up a bunch of sensor data, and we ran this all over 3G modems. And so we were paying the bills for these 3G modems and realized, wait, we're spending a lot of money on bandwidth. Turns out that something like 80% of the overhead was HTTP headers, and then the JSON body was, that last 20%. So switching over to something like a WebSocket made a ton of sense and then saved us a ton of money. All right, how does it work? So we're going to go from the nuts and bolts to the business stuff. We're going to show a lot of interrelated snippets, but I'm going to always come back to one basic overview. And I know you look at a diagram like this coming in cold, and it's a little anxiety-inducing. There's a lot of stuff going on. A total side note, unrelated, turns out that dogs yawn when they're anxious and uneasy. So this was Hopper's reaction to seeing this diagram. All right, let's look at our life cycle. So here's our life cycle. We're going to run through this. I'm going to put some code up on the screen. This is more of reference just to kind of get us an idea. I liked putting the concrete code next to the step just so that we can see, but we're going to dig in and look at each of these as we go through. So the client connects to a cable. Cable is kind of this generic abstraction as to what is gonna kind of be the WebSocket or the controller type thing that it will handle sending information back and forth. If we look at this, on the client side, there's a very simple way of saying, hey, let's pull in this thing and let's create a consumer that's going to handle this cable. The server confirms this connection. It can handle things like making sure that the right person is subscribing to the right things. The client will subscribe to specific channels. So the channels are coming in over this connection, and it's declaring the things that it is interested in. And then the client can send messages up to the server. So these messages are all posted over that channel that goes up to the connection. That's part of our cable. And finally, the server can send the messages back down to the client. So this is the other direction where the server is pushing messages down over the connection on the channel that they're interested in. So as part of this, I spent a long time reading and rereading the ActionCable guide. And one of the things that kind of came out of this was there's all of these different abstractions. ActionCable handles a lot of things kind of like Rails handles the normal like HTTP requests, but puts things into controllers and views and routes. And all of this happens in the ActionCable world, and there's all of this terminology and jargon that goes into it. I wanted to acknowledge that it's there, and we're going to work on defining some of these things, but I don't think any of these things in particular are that important for digging into kind of seeing how the pieces fit together. All right, so we're going to get the client to connect to the cable. We don't quite understand what a cable is yet, so we're going to kind of look into it. Back to our overview, we want to look at this part. So how does it open a connection? Well, we're going to start with the client. Most of the time, the client is JavaScript running in a browser. It doesn't have to be, but that was our default in our chat app that we started with at the beginning. And I looked into ActionCable and dug through the code and wanted to find out where the WebSocket was created. And with a little bit of searching, found that it just calls this WebSocket function that's native in the browser. But there's some magic going on, and so I wanted to figure out what was going on. So I looked in the browser, opened up my trusty dev tools, as web developers like to do, and I noticed that there was an HTTP request. It had headers and responses, and it really looked like it was standard HTTP, but it wasn't. It was WebSockets. And so, being from the internet, we go and read the RFC. And then we get really confused and not understand what the RFC is trying to understand. So that's led down this rabbit hole of trying to figure out what exactly is going on. So before we can understand how a WebSocket works, let's step back and just look at just a regular HTTP request. I want to kind of go to like a fundamental atomic level wherein I'm going to treat TCP connections as atomic, and we can't split those up. So we're going to think about things that we can do in Ruby. And what we're going to do here is we'll go down and talk about a socket level in the TCP connections, and then kind of build up from there. So the client is going to connect to a server. It establishes a TCP connection. And then the client will make a request. The server gets that request and responds back with the response. In old school HTTP1, it would just close the connection and be done with life. There's a lot of beautiful, beautiful things about this. I do want to make sure that folks understand that when we're talking about the socket here, it's like writing to a file. When we sent a request, we just wrote some bytes to a file just as if you were writing JSON or Markdown or something into a text file on your computer. And the server kind of did the same thing back to us. It wrote a bunch of bytes, and then through the magic of TCP, the operating system gave us those bytes. So that was the abstract how it works with the request. How would we do that in Ruby? So it's really about a 4-line Ruby script to do this, plus the actual body that we're going to deliver. And this body is just a couple of headers for HTTP. The hardest thing to figure out here was that we had to have goofy line endings because of legacy reasons. And so there was a bunch of carriage returns in addition to our new lines, which just made my slides kind of ugly. So what we did was took this bit of code, pointed it to my local Rails server and watched the logs. And once I sorted out all the bugs and got it to work, I saw 200 OK, which meant the Rails server thought, hey, this worked. One of the things that was interesting is I have this one line where I'm going to read the response. And I just ran socket.read and puts out the reply. And it was just a bunch of text. So it was just a plain old text file with headers, an empty line, and then the HTML body. All right, so that's kind of the basics of how HTTP works. So how do we get from that to a socket? So we go back to our diagram, and we talked about the GET response at the beginning, but now I want to talk about what's going on the client as we're upgrading. So before we had this is what our Ruby code just did. And before, it returned a 200 OK. We need it to return a 101 switch protocol. When we get that response, we'll have this magic conversion of the GET response to some sort of bidirectional socket. And I thought about this and said, well, that's some magic. So let's write the Ruby code to make this magic happen. The exact same Ruby script, however, a different body that we're going to send over to the server. It's a little more complicated. It has some goofy looking things in here, like it's not an HTTP protocol at the top. You see a WebSocket or WS connection, and then a few other headers like, hey, I want to upgrade to a WebSocket. But after a little bit of debugging, I pointed this at my local Rails server, and I got a successfully upgraded WebSocket. The next line was also successfully disconnected, but I left that part off. And then when I went through and I looked at what came out of the socket.read, I got plain text back, and it looked like what I needed. So we ran all this, and we have been able to upgrade it to a socket. And what's going on here is we send some text over and get some text back, and then once that's finished and we have read these headers, we now have a socket connection that's maintained open. So it doesn't close that connection until the client says we're through. So let's go back to the browser and take a look. And sure enough, what was coming back with our kind of simple, naive Ruby script, we were getting the same thing on the browser. And you can see right down here that we got upgrade WebSocket, and the same thing, connection was upgraded. So cool. We've gotten a client to talk to things and upgrade our connection. We haven't gotten very far. We're just over to the other side of that connection. And so we want to figure out what the server is doing. We went through the real basics of how a client sends an HTTP request. And so let's go over quickly how a server would handle that. It uses rack. Most things in the Ruby world use rack to handle HTTP. The nice thing about how this works is you have things like, an environment that gets passed in that has all the context. This will be things that the web server knows and understands. It can be things sent down from other parts like authentication and other environment settings that are being passed in. And then rack just replies back with OK, here's my status code, in this case 200. Here's some headers. I just gave one. And then here's the body of the response. And then we run it. So let's look at how that actually works. In a typical Rails app, these things are layered on top of each other as kind of middleware, but you can just stack and hook together different wrap applications, rack layers in between things, and have the responses go through. And what happens is the request comes in from the web server. It makes a call, passes in the environment, which calls the next thing down, passes in the environment, calls the next thing down, and then it goes, cool. And in our case, we'd be responding now, and then it makes its way back up until eventually the web server gives the response back to the client over the network. This is great, but at nowhere in here does it make sense to have a connection be upgraded. It's very clear. You pass parameters in and you return. But we need something to stop that. So some very clever people came up with this hack called rack hijack, and it works great. And to go over how this happens, the request comes in, it'll call into the rack app, and if it happens to have this thing as part of the environment that's being passed down called a rack.hijack, it'll invoke that, in which case it falls over and establishes a connection, effectively throwing away the rest of what would have happened with the method calls into the different rack procs. So how does this work? To find an example of it in the ActionCable codebase, there was a test. And there's a lot of stuff going on, and most of it doesn't matter, but what is important to know is, wait, this socket pair returns an IO object, then they set that to the rack hijack, so that when it calls it later, we now have an IO object. So as we were going through this request, we can just say, oh, actually, on that connection, we just want to associate these two. And when we do, we're able to connect the sockets. So one of the things that didn't quite fall into the stepping through how everything works was cookies. But it's pretty important, and since we were talking about how the connection is handed off between HTTP right now, I thought this is a kind of good timing. So we're going to take a quick detour and look at those. WebSockets and ActionCable doesn't have the same context as the normal HTTP request. However, it has headers, and cookies are just HTTP headers. If we go and look in our browser, we can see the list of the cookies. But we could also go through and see these same cookies, if we were looking at the response body from our simple Ruby script. But this is important because we need a way to pass information into these connections. And we wind up using it in something like this, where we are establishing a cable connection, and we need to figure out who is who. So in our chat room, we want to make sure that the right people have the right handles. So we can do that by passing a cookie in. Luckily, the HTTP headers are there while the connection is being established, so we're able to grab them. This is Hopper to remind me to take a drink of water. All right. The client subscribes to a channel. It does this with a subscription handshake. And we're getting up into a little more of the business level logic, less of the fundamental nuts and bolts. What we are interested in our overview is how do we get from the client all the way down to Redis. So what's going to happen is we establish our connection, and after it's all done, we've been over all of those steps. It's upgraded. We've got this connection. The server says, "Hey, welcome," and the client replies with, "Hey, I want to subscribe to a channel called Room Channel." And then the server acknowledges that. He says, "We confirm your subscription." So I went and looked in the browser, and under the Other tab in Chrome, you can actually click on the WebSocket connection. In this case, it's called cable. And you can see all of these things happening, where you see it as being established. The server sends down the welcome event. The client demands being subscribed to rooms, and the server says, "Sure, no problem." And then it pings a lot to make sure the connection stays active. So subscribing to a channel means that we need to get updates for that channel. So that means that we need a way to publish and subscribe things. So what we need to figure out now is, how does Rails handle that? There isn't anything in the traditional web request that would handle something being updated based off of some sort of event. and it solves it by using Redis Pub sub. So if we come back to our overview, we're interested in this part right here, and we want to know how the publish-subscribe cycle works. And this is just a way to centrally, the events can go into one place, and it will make sure to notify everything that cares about it about whatever that event happens to be. So to figure out how this works, I initially turned to the Redis command line, which is great. So I've got two terminal windows open. I have one that's going to be my server, one that's going to be my client. They're both just running on my laptop. On the server side, I typed in Redis CLI, and then I'm going to type subscribe channel 1. When I hit enter, it comes up and says, hey, I'm listening, and then just blocks. It hangs there. So on the client side, we type in Redis CLI, and then at the prompt, we run publish to channel 1, and we're going to give it a message of hi. And as soon as we hit enter, on the server side, the terminal updates and says, I got a message, it was on channel 1, it said hi. And we could just do it again, and it happens again. And it was very snappy. It happened right away, and it was a great way to kind of see, just let's play with Redis and figure out how things work without having to worry about anything. But being RailsConf, we want to know, how do we do this in Ruby? So 2 scripts. On the left side is the server, which will listen and block. On the right side is the client, which will publish. And the way the client publishes is it'll just run once, pass whatever was passed into it on the command line, and then exit. I also tried to make the output kind of look like the Redis CLI. All right, so we start up our server. We run Ruby, we're going to subscribe to a channel. And we do the same thing. It doesn't actually print out output, so it was just hanging here. And now we go over to the client, and we're like, hey, Ruby, publish, hi. And the server updates right away. And we do the same thing. We say there, and then the server updates with there. And the same thing. It's the message over which channel and the payload that was given with it. So this is how Redis kind of handles these things, and it works out to be a really great way for Rails to encapsulate a problem, which is how can we pull off pub sub on a web server and have a piece of infrastructure that can just kind of handle all of that. And Redis is great at that job, and so we're able to just kind of put an instance there and let all of our Ruby code and business logic talk to that, and it will handle the, like, here's the things I need to care about, and here are the people that need to be updated. All right, the client is going to send messages to the server. So we're getting even more high level at this point. Going back to our diagram, we want to know how stuff is going from the client up over the socket. So if we want to know how things are going up over the socket, we need to understand the format of how WebSockets construct their payloads. Pulled from the RFC, I had a bunch of information. I sat and looked at this ASCII art for a long time, and eventually went and kind of broke it down into a much more abstract thing after consulting a dozen or so different blog posts to figure out what was actually happening under the covers. What's nice about this is it's very simple at its core. It's binary data, and so there is definitely some confusion as to like what exactly is going on, and it's harder to poke at and understand. But it starts out with an opcode and then a length of how long the data is going to be. The client can also send up this mask, which isn't all that important. But the thing that was intriguing, especially since I was paying bandwidth bills, was the overhead per message was like 2 to 10 bytes. That's like a character or two. So when we were comparing that to the HTTP headers that we had in the past, this is extremely slim and lightweight. Should note that that diagram is not to scale. And if we go back to our dev tools in the browser, we can see, yep, all of these messages are getting passed back and forth. And the browser will even let us kind of dig in and look at the payload values in the WebSocket message construction. You can see the timestamps and the sizes and in addition to all of the kind of the contents of the body. So that's the client talking up to the server. The server needs to send things down. And so we're going to look real quick at our overview. It's not just from the cable server down. It is also from Redis up, which is the pub sub, but pub sub doesn't do anything by itself, so it's the other things telling pub sub to do things. So this could be anything from background jobs finishing and needing to announce something, or somebody typing in a different browser window somewhere far away, and the message is coming in and being added to a chat room and then sent back out. So we'll look at a little bit of the high-level code. We're starting to get up to the point where it's in your Rails app itself. And we can go through real quick the different steps. We start with ActionCable. On the back end, we can broadcast to a channel. In this case, I'm sending two parameters, one called message that says hi, and then another one called 1 with the value of 1, just so we can see that there's multiple parameters coming through. That converts it to JSON with an identifier in our actual message body. And then that JSON gets delivered to the client, and Cable.js, the Rails JavaScript code, converts it to JavaScript for us, and then calls back on this JavaScript function and said, hey, you received this data, and here's what it is. In this case, it's just a little snippet of code from our chat app earlier where we're like updating a div and putting in the message. All right. Let's recap. That was exhausting. So let's simplify our diagram just a little bit, and we'll go through the steps just to review. We connect to a cable. The client talks to the cable server. The server can confirm that connection. The client can subscribe to a channel, so we go all the way up to the pub sub component of this. Once all of that setup is done, now the client is able to send messages up to the server, which can then get broadcast out if they need to be, and the server can do the same thing, where it can get in other information from anywhere, send it through the pub sub, back through the cable server, and complete the loop there. All right, that's all.